Hi, in this video we will write a hash function. So consider a scenario in which our application has a lot of data in an array and that is continuously growing, which is slowing down the data retrieval process. So we decide to implement a hash table instead of an array, and this hash table will have 5 buckets or slots. Now, as the name suggests, a hash table needs a hash function, and it is this hash function which we are going to write today. We will write this hash function in Python. So this hash function will receive an argument, and this argument is the actual data that we are storing in an array, and we will use this data to calculate the hash value. We declare a variable hash value which this function will return after the calculation. Now, the first thing that we have to do here is the data or the input that we have received, we encode this in UTF-8 format. The intention of this conversion is to ensure that whatever the input we have received, we convert it into a byte stream, and then we will use each and every byte of the input to generate a hash value. And here we generate the hash value. It is a very simple hash function where we are XORing each and every byte, and that completes our hash function. Now the next step is we will evaluate the characteristics of this hash function. Do remember, a good understanding of these characteristics will always help us to choose an appropriate hash function. These characteristics are one way, avalanche effect, collision resistant, and speed. When we say hashing is one way, it means we cannot use the hash value to convert it back to data. Now let us see how this hash function performs on this front. For this, I create a new file and we call it test hash v1. And now in this file, we'll write a function test one way. And I start by creating two arrays, one for first 10 alphabets and another for 10 numbers. Now I will write a for loop which will iterate through each and every element of both the lists and print the hash value of each and every element. If we observe the output, we will notice that the hash values of alphabets is same as the actual ASCII value of the alphabets, and same is the case with the numbers. We get the ASCII values of these numbers. So yes, we are using only one character, but even if we use multiple characters in a string, it will be easy to identify the data or the input value provided the hash value is given to us. So in this case, we can say the test or the characteristic of one way is not fulfilled here. Now we will look at the next characteristic. Avalanche effect suggests a hash function must generate a significantly different hash value when there is only one bit of difference between the two input values. So in this test, we will take two strings and there is only difference of 1 byte between the two strings, and we'll see how this hash function performs. If we observe the output of the hash function, the hash value does not change much when we change the input string from Tim to Tin. So this hash function does not do very well with regard to avalanche effect. If this video has been of any help to you, please like the video. And the next characteristic that we will look at is collision resistance. A collision occurs when two separate inputs generate an identical hash value. And a good hash function should offer a very low risk of collision. And to test this hash function for collision, we'll write a function which will generate random strings of 3 to 15 characters in length, and then we will generate the hash values of these random strings and see whether the collision occurs or not. Now we look at the output. You will see that the two randomly generated strings, have the same hash value of 29. It was generated in the 7th iteration of the loop. So we can easily say that this hash function is not very good with collision resistance. Now the last characteristic in this video is about the speed of this hash function. For this, we will run two tests. In the first test, we will generate the hash value of 15 million randomly generated strings. In the second test, we will generate a hash value of 32 megabyte long string. So this test takes around 30 seconds to process 15 million strings. So is this fast enough? Well, the answer is it depends. If my requirement is to process say 15 million strings in half a minute, then yes, it does satisfy the requirement and it is fast enough. Otherwise, it is not fast enough. Now let's look at the other test. So if you look at the result again, here it's approximately 28 seconds to process 32 megabytes of characters. So the answer remains the same. It depends. If this time is acceptable, then this function is good enough. Otherwise, this function is slow. And this concludes our test. To summarize, this function did not do very well at different parameters. For one way, if you remember the input of alphabets that we passed on to this function, it returned the ASCII values as the hash values. And when it comes to avalanche effect, the two input strings that we shared, Tim and Tin, for both the values, the hash value it generated was not very different. And when it comes to collision, we were able to identify the collision very easily on this function. And last, the speed. Again, it depends. Now the question is this function still a good function to use? Remember, the intention of writing this function is to store the data in a hash table of 5 buckets. In the next video, we will see how this hash function fares when it comes to storing the data in hash table. Thank you for watching this video. Please share this video among your friends if you think it will help them. And if you want such videos in future, I request you to subscribe to this channel. Keep learning. Thank you.